Hi everyone, this is Mrs. Eggerding, and you are watching video 2 of Unit 7, and we are going to introduce the graphs of exponential functions to you. First thing about the exponential graph that you should notice is yes, it does have a horizontal asymptote. The end behavior, as x goes to negative infinity out here, it does flatten out and give you a horizontal asymptote at y equals 0. Domain of all exponential functions, negative infinity to infinity. The range is going to be 0 to infinity. Notice this 0 has an open bracket because it is not included in the range. And then the y-intercept, well, if I make my x-coordinate 0, any number to the 0 power is going to be 1. There's your basic exponential graph. Everything else we're going to do is going to be variations on this. So let's see what happens when I have a base bigger than 1. So in this case, 3. Let's go ahead and make our t-chart for this to get a feel for what this looks like. So if I start with negative 2, 3 to the negative 2 power. Now negative exponents, remember, mean you do the reciprocal. So this is 1 over 3 squared, in other words, 1/9. 3 to the negative 1 power is the reciprocal, 1/3. 3 to the 0 is 1. 3 to the first is 3, and 3 to the second is 9. So if I go ahead and plot those points, you get a feel for what this exponential graph looks like. And we have our domain, all real numbers. We do have our horizontal asymptote at y equals 0, and that's this flattening out here. Your range is 0 to infinity. My y-intercept here will be 0 to 1, or 0, 1. All the same information as our basic graph. The only distinguishing characteristic are the values that you get in your table. So let's go ahead and take this exact same function, but this time we're going to apply some transformations to it. So this minus 1 is going to move the graph down 1, and that's going to affect your horizontal asymptote and your range. The other transformation up here, the plus 2 in the exponent, that moves the graph left 2. So let's go ahead and fill in the information we know. Domain, all real numbers. Horizontal asymptote has been moved down 1. So instead of being at 0, we move it down 1, and it's at y equals negative 1. My range is now going to be negative 1 to infinity. And my y-intercept, well, you plug in x equals 0, and you get 3 to the 0 plus 2 minus 1. That's 3 squared minus 1. 9 minus 1 is 8. So the question then is, well, where's that left 2? Well, let's build our table of values and see if we can't find it. If I do negative 2, negative 1, 0, 1, 2, plugging in negative 2, I get 3 to the negative 2 plus 2. So I get 3 to the 0, which is 1, minus 1 is 0. 3 to the negative 1 plus 2, well, that becomes 3 to the first, which is 3, minus 1 is 2. 3 to the 0, we already did, is 8. At 1, you get 3 to the 1 plus 2. That's 3 to the third, 27 minus 1, 26. That's way off our grid. We're going to run out of space here. So there is our exponential function. Only basic information that changed was my horizontal asymptote and range from the transformation, and then the y-intercept. So again, where'd that y-intercept go? Well, on a standard graph, the y-intercept is at 0, 1. If we apply the transformations left 2, down 1, that y-intercept gets moved to a completely different location. We're not going to focus on where that y-intercept goes. You just need to be able to create the information and then create your table of values. Alright, so let's take a look at an example with the base is not bigger than 1. This one with a base of 1/2. What's that going to do to my table of values? So if I plug in -2, now remember, negative exponent means I want to do the reciprocal. So that becomes 2 squared, which is 4. 1/2 to the -1 becomes 2. 1/2 to the 0 is 1. 1/2 to the first is 1/2. 1/2 squared is 1/4. So if I plot these ordered pairs, I still get that exponential graph, but now it's going in the other direction. My domain stays the same. My horizontal asymptote hasn't changed. My range stays the same. And my y-intercept stays the same. So all we did is change the look of the graph by giving it a different base. If we go ahead and apply the transformations to this, transformation of up 2, that's going to affect your horizontal asymptote and the range. The -3 is a transformation right 3. Listing my information, domain doesn't change. My horizontal asymptote has been moved up 2, so it's at y equals 2. My range will be 2 to infinity. Now what about that y-intercept? Well, if x equals 0, I have 1/2 to the 0 minus 3. 1/2 to the -3 is 8, plus 2 is 10. So I have a y-intercept up here at 10. If I make a table of values, and of course you can always get these table of values from your calculator as well. I think 0 is going to be the best I can do. Going backwards, the numbers are going to get too big. If I go to 1, 1/2 to the 1 minus 3, that's 1/2 to the -2, which is 4, plus 2 is 6. At 2, I have 1/2 to the 2 minus 3. That's 2 plus 2 is 4. 1/2 to the 3 minus 3. That's 1/2 to the 0 to 1, plus 2 is 3. And then at 4, I have 1/2 to the 4 minus 3. That's 1/2 to the 1, plus 2. That's 2.5. 2.5. And so there is my exponential graph. Again, you don't see that right 3 transformation obvious until you think about if the original y-intercept at 0, 1 is moved right 3 and up 2, that's where it gets moved to. So let's do a little summary of all of the things we've talked about. First of all, we have this thing growth versus decay, and that's what we're talking about with this base. If this base is greater than 1, you get something called growth. It's because this graph is increasing as you go from left to right. A base that's between 0 and 1, like the 1/2, goes down from left to right. We call that exponential decay, and it's decreasing. And as we get into more word problems, we're going to use those words more often. Okay, the asymptote of all these exponential functions is going to be the k value. The range is going to be k to infinity, unless there's a flip. So it could be negative infinity to k if there's a reflection. The domain, good news about the domain, it's always all real numbers. And then the y-intercept. You're going to make the x-coordinates 0 and evaluate it from there. Very much the same with a lot of things that we've been doing so far. Page 414, numbers 25 to 31 odd, ask you to graph a couple of these, focusing on domain, range, and the asymptote. There is an entrance slip, also using that vocabulary on Schoology, so make sure you take that quiz. And bring your questions to class, and we will talk to you later. Thanks.